The division property of exponents, and how do you use the division properties of exponents? As in the last video, we're going to look at an example to see this. 6 to the 7th power is the same as 6 times 6 times 6 times, 6 times 7 times, all over 6 to the 4th power. So I would put 6 times, and I would have 4 6's down there. Now I'm going to eliminate every 6 over a 6, leaving me with 3 6's on top, or 6 to the 3rd power. This shows me that 6 to the 7 minus 4 is 6 to the 3rd, or b to the m over b to the n is b to the m minus n. The quotient of powers property means the difference of exponents. At this point, let's look at another example that has a fraction or a quotient in it. 3 over 4 raised to the 5th power is going to be the same as 3 over 4 times itself 5 times. I see that this is going to give me 5 3's on top and 5 4's on bottom, so I can simply write this as 3 to the 5th power over 4 to the 5th power. So in my letter example, the numerator over the denominator, or n over d, will give me n to the e over d to the e. So the positive power of quotient property says a quotient of each is raised to that power. Now what if that power was negative? So if I took that same fraction, 3 over 4, and that same power of 5 but made it a negative 5, negative 5 is the same as negative 1 times 5. So if I distribute that 5 to both of them, then I get 3 to the 5th over 4 to the 5th, and this is all to the negative 1 power. Back when we were looking at the patterns of exponents, we saw that a negative caused a numerator to move to a denominator, but it also caused a denominator to move to the numerator. So our result is an inverse of the fraction raised to the opposite power. If we look at the letter example, n over d to the negative e power gives me d to the positive e over n to the positive e. So this shows us the negative power of quotient property, which is the reciprocal of the quotient raised to the opposite power. It's always important to keep in mind that the method we're using to simplify these expressions is to expand the exponent, then eliminate what they have in common, and simplify them into one base. A pessimist sees the difficulty in every opportunity. An optimist sees the opportunity in every difficulty. Winston Churchill.